Yeah, welcome to Seller Team class. STEM and science made simple, explaining simple scientific concepts using science to make lesson meaningful. So, simple thing, what is a force or pushing and pulling? We just want to explain the concept of pushing and pulling, why we call it a force and which one is more effective. Now, on the board, you can see what is here. Now, let's go. Now, which is more effective? Is it pushing or pulling? And what will happen? Let's look at this. Now, activation of knowledge. Why do people pull luggage instead of pushing? Look at this. Almost everybody, we can observe, almost everybody would like to push, would like to pull than what? Pushing. Why is it so? Let's look at the science behind it. Now, let's look at this video. Observe this video carefully. Good. You can observe that the first person is pushing object at 25 degrees. The second person is pulling object at what? The same at 25 degrees. The force angle is 25 degrees, 25 degrees. Which of them is more effective? Let's analyze this. Now, before that, let's answer this question. Now, why did you observe? What did you observe in the video? Which object require more efforts? Is it pushing or pulling? Why? What will happen if the surface was so smooth, rougher and smoother? You know, two things happen. Effect of friction will happen here. Is it smoother and rougher? Which of them? Now, let's consider this. Let's consider the effects of friction now. When pushing, part of your force presses the object harder on the ground. So we can observe that when you push objects, this is the object. If you push it forward, so a force laying on the object downwards and also a downward force occur. So these two things, if you push the object forward, this what happen, you increase the normal reaction. You increase the normal reaction, and it's a normal reaction, and this is the main force. This is the weight of the object. So when you push the object, you are increasing the normal reaction such that your force, you increase the weight of the object, so the normal reaction need to increase to balance the weight of the object. In a nutshell, you also increase the friction. So when object is pushed, even though it's pushed, the frictional force also push. Now, what happened to pulling? In pulling, if you pull an object upward, part of your force lifted the object upwards. This reduces the normal reaction, also reduces friction. This is the main analogy of what happened here. Let's enter into, let me explain this further. Now, look at this. Both cases, the force is applied at 25 degrees, right? And when you push, this is pushing, this is pulling. So when you push the object, you are exerting a force. You are exerting a force here. This is the ground. So as you push the object forward, what happens? A force is exerted on the object here, on the ground. Now there's normal reaction N over here. So normal reaction here. So you can observe that the too much force is concentrated here, increasing the frictional force. But when you lift the object, so pulling reduces. When you pull the object, as when the object is being pulled up, it reduces the effect of the force on the ground. So in effect, this one, more effort is needed. This one, less effort is needed. So pulling will be by far easier, less effort than this. Let me explain further on my next slides. Now let's have look at the which of them me. Look at the diagram again. So when you push in, some energy is wasted. As I've said, as you push the object, more energy is wasted and it increases the frictional force on the ground. So as this object is pushing, you can observe it's pushed the object here. The effect of it on the ground, it increases the weight. The weight of the ground increases. and the force N, which act upwards, must also increase. You know, as the force increases, as the weight increases, the normal reaction must also increase to balance the object on the ground. So there's a lot of wasted efforts here. But this one, let's look at pulling. If you pull the object up, this is the ground. So this one is like the force is acting upwards. So the object is in effect being lifted a bit. As it's lifted, so the normal reaction, the effect of normal reaction will also reduce. So the weight of the object now will now increase. So this object will move faster than this object. Let me explain better. Okay, let's look at the next slides. What happens when you push an object at an angle? So this happens, the horizontal movement, move the object forward, this move object forward, and vertical move object backwards. As I've explained, this is the normal reaction. Is the upward force that exists on every motion. If you put upward force that exists to balance an object on the plane surface. So if this thing is here, because there's a normal reaction acting downwards, which balances the weight, so the object must be able to stay on the surface of an object. So the book here experiences normal reaction N and the weight W. The book is able to stay on a surface here because N is equal to W. That's why you're able to stay here. N here, N is equal to W, which means that the normal reaction force on the object is equal to the weight. So the weight is able to balance here. So as I say, if you push an object downward, you increase the total weight downwards on the ground. So the normal reaction increases. So the more you push, the more you increase the weight on the ground. So the normal reaction here must also increase to balance the weight. Normal reaction increases. This increases the frictional force, which opposes motion of the object. So as the object is being pushed seriously, it exerts a force on the ground, increase normal reaction, increase frictional force, and also it opposes motion. So the object being pushed like this will move less than being pulled. Let's look at this. I think it's well explained here. So it opposes the body forward harder than moving forward. Let's look at this. So what happens when you push an object? Let's look at opposite. It increased frictional force means more energy is lost. What happens when you push? The same thing when you push. So when you push, there's increase in frictional force. Let me highlight it. When you push an object here, the same. If you push, there's an increase in frictional force because therefore there's more exert on the force on the ground. Also, more energy is lost. You know, frictional force is a minus force. It's the more the frictional force, the less the energy consumed. So more force required to maintain the motion, more force required. So more energy is being needed here. Pushing down object makes the object less harder. So pushing down the object makes the object press the object harder. It presses more harder as a difficult to move, opposes to motion, and you need more energy for the object to move. So it increases frictional force on the ground, making it more hard to move, as I've explained very nicely. So let's look at the opposite. Now pulling, it reduces the normal reaction. When you pull object up, your force lifted the object slightly. So when this object is being pulled up, when the object is being beat the ground, if you pull, you can see that the angle is moving upwards. So the force is being lifted to setting it on the ground. So the effect of the normal reaction reduces. The force that keeps the object balanced, there's no much pressure on it, so it reduces. So what happens? As it reduces, the less the normal reaction, the less the frictional force. This is the formula. Frictional force is equal to coefficient of reaction plus normal reaction. So the less the normal reaction, the less the friction. The more the normal reaction, the more the friction. So because frictional force is directly proportional to the normal reaction, the coefficient. So as I've said, This reduces normal reaction. So this in effect means that less friction depends on normal reaction from this formula. So this one you can observe that he put this little lifts on the object on the ground. So frictional force is less here. Normal reaction reduces, and what the object it does not, the object movement become very fast. Thank you. Now, effect on motion. Even though you are applying the force, part of it is wasted in with respect to the pull. If you pull an object here, this is pushing. If you push an object here, you wasted the effort, so your object is harder to move. You need more energy to do this. Let's look at summary. I hope I've explained myself. Pushing and pulling, one need more energy, one less energy with respect to frictional force and normal reaction. Let's look at this summary. I summarize everything here. So this means that if you push object, the normal reaction increases, frictional force increases, more energy is used. Excuse me. If you pull an object upwards, so there's decrease in normal reaction, which means low friction, less energy. So you want to use less energy to do the work. So less energy, more efficient movement. So thank you for understanding this how it is. So pull is better than pushing. That is why you go to airport, you go to market, everybody have a cart, they try to what? Pull it to reduce energy. Okay, let's look answer this question. Give one example of forward motion in your daily life. Forward motion in your daily life. When you have seen something move backwards, what causes it to move? Yes, shall we think? This is what ask our students to have to put them in the mind of thinking. Have a mental thinking, critical thinking ability after this short lesson. Why do we pull doors instead of pushing sometimes? Sometimes the door is not working, you have to pull it. Pull it. That is no pushing. So now it's explained here. I've explained everything here. Thank you for watching. This is my channel. Thank you. This is Science and STEM, simple but relative. Thank you for watching. Bye bye.